Hello students, today is the third day of the chapter Unit and Measurements. So this is very important class for competitive exam and the as well as the board exam because many one or two question come in your JEE or NEET from this chapter. So this lesson is very important. So before starting today's lesson, let's practice some units, some dimensions of the physical quantities. So first we have seen that the first quantity is potential energy. So you know that potential energy means mgh, mass into gravitation, acceleration due to gravity, and height. So the dimension of mass is m. This is acceleration, so L t to the power minus 2, and height is L. So it comes m1 L square t to the power minus 2. Kinetic energy, as it is the energy, so it is equal to the potential energy, you can say, or you can calculate with half mv square also. So you will get same answer as well as the potential energy. Now universal gravitational constant. So you know that force equals to g into m1 m2 by r square. So from that you can calculate g equals to f r square by m1 m2. So force dimension is m L t to the power minus 2 and r is L, so L square, m is m square, so you get this one. Okay. And capacitance means q by v, that means charge by potential. So potential means work done per unit charge, so q square by w, q is at, okay, current into time, so at, and work done means m L square t to the power minus 2. So by calculating this we are getting m inverse L minus 2 t4 a square. So what is the power of electricity? Power is calculating by work done per unit time. So the work done is m L square t to the power minus 2 by t. So we get m L square t to the power minus 3. Okay. Let's see stress. Stress is force per unit area. Okay, force per unit area. So the dimension of force is m L t to the power minus 2. We have to remember these things, and the dimension of work done, because many times it comes. So force and area is L square. So it comes m L inverse and t to the power minus 2. So this is the dimension of stress. Okay, strain. What is strain? So see, this dimension of stress is equal to the dimension of pressure, because pressure means also force per unit area. So stress means stress is same as pressure. So what is strain? Strain means change in dimension. That means change in length or breadth or height. Change in length. You can say if the length is change of an object, so we are calculating the strain as change in length by original length. So I have written that change in dimension upon original dimension. Dimension may be length, may be breadth, or may be height. Okay, so see, if that is length, so it is L by original length. The dimension of length is also L, so L cancel out and it comes m0 L0 t to the power 0, because it is dimensionless. Okay, let's see what is the dimension of momentum. The dimension of momentum, so first we have to know the calculation. What is the, that is the expression of momentum. Expression of momentum is mass into velocity. So mass into velocity, it is very easy, m1 L1 t to the power minus 1. So solid angle, let's see solid angle. Solid angle is capital sigma, as you know that. So solid angle is capital sigma. So capital sigma means area per radius square. So area is L square, radius is L, so radius square is L square, so it will cancel out L square. It comes m0 L0 t to the power 0, but dimensionless. Okay, so frequency is 1 by time period, so equals to 1 by t, so it comes t inverse. Okay, m0 L0 t to the power minus 1. So as you have seen that the dimension of frequency is t inverse. Okay, so let's see some conversations of length, some important length conversion. Okay, so I have written here some conversion of length. So if this is 1 meter, so the upper sides are lesser than 1 meter and these are the more than 1 meter. Okay, so here you can see that 10 to the power minus 3 means 1 millimeter, 10 cube means 1 kilometer, we know that. Let's see 10 to the power minus 6 meter. 10 to the power minus 6 meter is called 1 micrometer. It is written as 1 mu m. This is mu symbol. 10 to the power minus 9 meter, that is called 1 nanometer, 1 nm. 10 to the power minus 12 meter, it is called 1 picometer, 1 pm. 10 to the power minus 15 meter, it is called 1 fermi or 1 fm. Okay, and it is also said to be 1 femtometer. So let's see 10 to the power 6 meter. 10 to the power 6 meter is 1 megameter. Okay, that is called 1 capital M small m. 10 to the power minus 9 meter, it is called 1 gigameter, 1 capital G small m. 10 to the power 12 meter, 1 terameter, 1 tm. 10 to the power 15 meter, 1 petameter is called 1 capital pm. 1 small pm is picometer, and whereas the 10 to the power plus 15 meter is 1 picometer. Okay, let's see some another important length conversion which we are going to use for our numerical. So this 3.08 10 to the power 16 meter is called 1 parsec. 9.46 into 10 to the power 15 meter is called 1 light year. 1.496 into 10 to the power 11 meter is called 1 astronomical unit. This is the distance between the earth and the sun. Okay, astronomical unit. So 10 to the power minus 10 meter is called 1 angstrom. Okay, it is written like that. 10 to the power minus 3 meter cube, here is meter cube is written, so it is called 1 liter. 10 to the power minus 3 meter cube. Okay, so these are the some important length conversation. So I request you please write down this length conversation into your copy, because it is very helpful for in future. Okay, so let's start our today's lesson. So as you know that today we are going to learn about significant digits. So what is significant digits? The digits whose value are accurately known in a particular measurement are called significant figure or significant number. Okay, the digit whose value are accurately known in particular measurement are called significant figure or significant digits. So let's see what are the characteristics of it. A choice of change of different units does not change the number of significant number, okay, or significant digit in a measurement. That means if you change the units, so it doesn't matter for the significant digit. So let's see an example. Suppose 11 meter. 11 meter has two significant number, one and this one. And here 11,000 millimeter, we can write 11 meter as 11,000 millimeter, but it has also two significant numbers. So to calculate, to know about how many significant number, how many significant digits in a number, so there are some rules to know about. Let's see what are the rules of significant number. So here I have written some rules, as you know. So I will give this in PDF form in the description box, so you can download and write in your copy. Okay, so the first rule is all non-zero digit are significant number. Let's see a number 234.62. so here you can see they're all non-zero digits, right? So the significant number is, all are significant, so 1 2 3 4 5, so you can write 5 significant number. Okay, 5 significant digits. Okay, understood. Let's see second rule. All the zeros between two non-zero digits are significant, no matter where the decimal point is, if at all. So that means a zero which is in between two non-zero digit are significant. Let's say an example, suppose 2036. So here these non-zero terms are significant, and this zero term which is in between two non-zero, it is also significant. Okay, so here that is 4 significant digit. So let's see another example. Suppose you have 2.3102. So here decimal point is there, but this 0 is in between two significant number, because non-zero terms are significant, so that this 0 will be also significant. So decimal points is not going to occur any problem here. So this is the number of significant digit is 1 2 3 4 5 5. Okay, let's see next rule, that is if the number is less than 1, zeros on the right of the decimal points but to the left of the first non-zero digit are not significant. What does it mean? That means if a number is less than 1, let's see 0.0234, okay, and 2 0. Okay, so here let's say 2. Okay, so here it is written that if the number is less than 1, so the 0 on the right of the decimal points but to the left, the right of the decimal points, this one, so decimal points, the right of the decimal point, that means this 0, and the left of the first non-zero, that means this is the first non-zero term, so the left one is this, so this will not a significant. That means this one is not significant because it is a 0, but it is before the decimal, but after the decimal, the first 0 term, okay, the first 0 term which is the at before the non-zero term, it is not significant. Okay, so the number of significant digit is 1 2 3 4 4. Okay, let's see another example. Suppose you have 0.000 2, 3, 4, 6. So here the zeros on the right hand side of the decimal points are these. Okay, suppose you have this one, so this one is also right hand side, but the zeros of right hand side and the left hand side of the first non-zero terms is this. So these are all non-significant. Okay, so the significant digits are these. So here it is 6 significant digits. Hope you understand this three formulas. Let's see the fourth formula. So the fourth formula is the terminal or trailing zeros in number without a decimal point are not significant. Okay, without a decimal point. Suppose a number which has terminal and trailing zero, that is 0, 2, 6, 5, 0, 3, 0, 0. Okay, initially also as it. So here you can see we know that non-zero terms are significant and the zero which is in between two non-zero terms is also significant. So these are all significant. But the terminal zero and the trailing zero are not significant if there is no decimal point. If there is no decimal point, then the terminal and the trailing zeros are not significant. So the number of significant digits is 5. 1, 2, 3, 4, 5. Okay. Let's see the fifth. The trailing zero in the number with decimal point are significant. The trailing zeros in the number with decimal point are significant. That means if it is written that 0.00210350, okay, so if this is a number, so you know from the from the third rules, we have seen that the initial zeros after a decimal point is not significant, so these are not significant. Okay, and these terms are non-zero, so this will be significant, and this one is in between two non-zero terms, so it will also significant. But the trailing zeros after a decimal point is significant. But if there is no decimal point, that in that case the trailing zeros are not significant. But if there is decimal point, so the trailing zeros will be significant. So a confusion can occurs. So from the characteristics of the significant, we have learned that a choice of a chunks of different units does not change the number of significant digits in a measurement. So if we change the unit, so it does not create problem for the counting of significant digit. But here if you written that 4.790 meter, you can write it in that way, that is 4790 millimeter, right, millimeter, and 0.004790 kilometer. Okay, so in that case 479 is non-zero, so this will be significant, and 0 here is 0 is trailing 0, and after decimal point, so this will also significant. So here is 4 significant term, 4 significant digit. But in that case you have seen that you can see that 4709 4790, so these three terms are significant, but this 0 is the trailing 0, but here is no decimal point, so this will not significant. So here you can see this is 3 significant numbers, and for that case these zeros are not significant from the rules of from the third rules. These numbers are not significant, these zeros, these only the significant numbers. So here is also 4 significant number. So as you can see, the same value but in different units gives us different number of significant digits, but it actually violates the characteristics of significant number. So to remove the confusion, we have to write in a specific way. Okay, to remove this confusion in determining the number of significant figures, the best way to report every measurement in scientific notation. Okay, scientific notation. Let's see what is scientific notation. Scientific notation is nothing but in the power of 10. Suppose we are going to write something with the power of 10 is named as scientific notation. Okay, so the notation is look like this: a into 10 to the power b. So here b is called order of magnitude, order of magnitude. Okay, and a should be greater than 1 and less than 10. A should be greater than 1 and less than 10. So let's see an example. Suppose you have given that the distance from the earth and the sun is this kilometer. Okay, so how to write it? So you have to write first a. Okay, a is a should be greater than 1. So here you see that is 15 number, so you can write it like this way. So a should be greater than 1 and less than 10. Okay, and how many if you put point is decimal point here, so how many digits are after the decimal point? So you have to count those digits. Suppose 1 2 3 4 5 6 7 8 9. So you have to write 10 to the power 9. Here you can see that 10 to the power 9 indicates the order of magnitude. Okay, so here you can see the 10 to the power 9 is indicates the order of magnitude, and the number of significant values is 2. Okay, 1 and 5. Understood? Let's see the sixth formula, sixth rules for counting the decimal point. Sorry, for counting the significant digits is the power of 10 is not a significant number. Suppose you have given that 4.70 into 10 to the power 5. So here 4 is non-zero term, 7 is non-zero term, and this is terminal 0 after decimal point. So these three all are significant, but this term is not significant. Not significant means better to say that it is not doing anything about in the counting of significant digits. So here only 3 significant digits are present. So let's see from the previous confusion we have, that is 4.790. So here you can see that is 4 significant numbers present. Okay, and here is also 4 significant number is present, but when we write 4790, so we have to write in the term of significant scientific notation. So if you write it in a scientific notation, so it comes like this, that is 4790 millimeter, right? So you can write like this. For see, we have to write greater than 1 and less than 10. So 4.790 we have to write like this. So now we have putting we are now we have put the decimal point here. So how many digits are after that decimal point? So 1 2 3. So we have to write 10 to the power 3. So here you can see how many digits are present there, how many significant numbers is present. Here it is 4 significant number is present. Okay, so this one is wrong. So let's see some questions. Let's solve some questions. So calculate the number of significant digits of that. So what will be the answer of this? See, the first 3 numbers are non zero, so this will be the significant number, and this will be the trailing zeros, but there is no decimal point, so this will not significant. So the significant number is 3. Here 0 term is in between 2 non-zero, and this will non-zero, and this will trailing. So how many? 1 2 3 4 5 only significant numbers. This is the terminal 0, this will not significant. 1 2, this will the in between 2 non-zero, so this will significant. This will trailing, so this will not. So 1 2 3 4 5. See, this here is decimal number is present, so 1 2 3, these will not significant because it is left side of the first non-zero terms and after the decimal number, so this will not significant. Only this 4, this will not significant, this will significant, and this one is trailing 0, but it is after the decimal point, so it will be significant. So it is 4 significant numbers. Here is also 4 significant numbers. Here is also, you can see 1 2 3 4 4 significant numbers. Here this 0 will not be significant, so 1 2 3 4 5 6 7. This term will not be a significant number because it is 10 to the power something. So 4 significant numbers. Here only 1 significant number. Here see, this is the non-zero term, so this will be significant, and this term will be after a decimal point, so this 0 will be counted as a significant number, so this will be 6. So these are the homework. You can take a screenshot, or I will give the PDF in the description box, so you can check it from here also. So do the homeworks. Okay, do the homeworks and give the answer in the comment section. Okay, so let's go ahead. Let's talk about the formulas of round off. So you all know, I think, that what is the formula of round off, but here something is special. So if, let's see the first formula, that is if the digit which has to be dropped is more than 5, then the preceding digit is raised by 1. Suppose a digit is 4.567. So if we drop this now, if we want to drop this 7, so as this is a greater than 5, 7 number is greater than 5, so we have to raise the preceding digit by 1. So we have to write 4.57. Okay, understood? Next, if the digit which has to be dropped is less than 5, okay, then the preceding digit is left unchanged. So if it is 4.564, now the 4 is less than 5, so we have to write 4.56. This term will be unchanged, this 6 will be unchanged. Let's see the third term. This is the main important formula. So if the digit which has to be dropped is equal to 5, if it is equal to 5, then we have two formulas, that we have to check the next digit of the 5. So if it is greater than 0, the next number, so then we have to add 1 to the preceding digit. Suppose, let's say an example by which you can understand. Suppose we have 40235 here we have to drop this number 5. So if we to know about that, what should we write? So check on the next number. If it is greater than 0, here is 2, so we have to add 1 in the preceding digit. Okay, 4.024. This will be the round off value. And if the next number is 0, so then what should we do? We have to add 1 in the preceding digit if the preceding digit is odd. Okay, and let's see an example. Suppose same example, 0235. Now it is 0 here, so we cannot check the after that is the next number of the 5. So we have to check the preceding digit. If it is odd, then we have to raise the number by 1 of the preceding digit. So this one, if this is odd, okay, if this is odd, and if this is even, so now the next number is 0, and check the first previous number. So previous number is even, so it will be left unchanged. Understood all the formulas of round off? So write down these formulas in your copy, and let's see the rules of addition, subtraction, multiplication, and division of significant numbers. Okay, so the addition and subtraction rules are same, and the multiplications and division rules are same. So let's see first what is the addition formulas for addition and subtraction. Okay, so here it is written that you have to see or find which number has least digit after decimal point, which number has least digit after decimal point, and round off up to that number after addition or subtraction. Okay, so let's see an example. Suppose you have to add 5.239 and 4.21. So you have to find which one has the least digit after decimal point. So as you can see, this number has least digit after decimal point, so it has only 2 and it has 3 digits. So we have to write the answer like this way, that in that number it is also 2, it has also 2 digits, same as the least one. So 2 digits after decimal point. So how to calculate this? So first add this one. Okay, so it comes 9.449. Then we have to write the up to 2 digit after decimal point. So we have to write up to this. So check the next digit. If it is greater than 5, then round off. So it is 9 here, so it is greater than 5, so I have round off it. So 9.45 it comes. So it is very easy, and same for the subtraction also. So when you subtract from this value to this value, so this one has less digit after decimal point. Okay, so it comes like this. So we have to write after 2 digits. Okay, 2 digits after the decimal point. So here you have seen that this one is 9, so it is greater than 5, so I have to round off this one. So 1.03 it comes. So this is the value. Let's see the multiplication and division. So you have to find the least significant number here. Okay, for the multiplication and division, you have to find the least significant digit. Here it is a least digit after decimal point, and here it is written that least significant digit, and the result should be up to same significant digit after round off. Okay, so suppose 4.410, here 0 is also significant, you know that, because it is after a decimal point, and we have to divide by 1.20. So in that case, the significant number is 4, and here in the significant number is 3, right? Significant digit. So the answer should be 3 significant digit. So if we divide it, it comes 3.675, but it has 4 significant number. 4 significant number, right? So we have to write it up to 3 significant values. So 3, 6, now 7. 7 and next number is equal to 5. So how to round off? How to round off it? So check the next number is 0. Then check the previous number, it is odd. So we have to add 1. So it comes 3.68. Okay. This will be the value of the division. Let's see the multiplication. So same rules applied for this also. So 4.410 into 1.1, so it comes 5.292. So here you can see we have to write it in three significant number, because least significant number is 3. So 5.2, and if we write 9, so after that it is less than 5, so we can write 9 only. We do not have to change the number because the next number is less than 5. So let's see another example. Suppose we have to multiply 298.2 into 12.2. So it comes 3638.04. Okay. But here you have seen that the least significant number is this one, 12.2. So it is 3 here. 3 significant digits are there. So this is the list. So the result should be with 3 significant digits. But here you have seen that there is 6 significant digits. So how to write 3 significant digits? So first write the 3 significant digit. First one, 363. Okay. This is the 3 significant digits. Next, check the next number. If it is greater than 5, so add 1 to that of 3, and if it is less than 5, so it is left unchanged. Okay. So here it is 8, so we have to add 1. So this will not. So 3, 6, 4. Okay, 4, and 8 should be 0. So now you can see that this number has 3 significant values, 1, 2, 3, 0, because there is no decimal point, so trailing zeros will be not significant. So here you can see only 3 significant number is present, but the answer is almost near to that of number, right? So we have to write like this. So I have given also some homeworks to you, so you can do this in your homework copy, or you can give the answers in the comment section. So I will check it. Definitely I will check it. So the first homework is solve the following with due regard to significant figure. So this is, we have to calculate this one, and you have to write with same significant figures. So this will same, here it is, that means subtraction. So subtract the due regards with due regards to significant figures. So we have to subtract this and write it as significant numbers. And this one is very important numerical. It can come in any competitive exam. It has already come in JEE, I think, JEE. So if the dimension of force, velocity and time is written as F, V and T. Okay, if we write like this, the dimension of force is F, velocity is V and time is T respectively. So calculate the dimension of mass in terms of force, velocity and time. Okay, so you have to calculate the dimension of mass in terms of force, velocity and time. Okay, using the method of dimensions. So it is very important. If you do this, then give me the answer in the comment section, or you can send me personally. Thank you. This is this much for today. So hope you enjoy this lesson. So this is very important lesson. So next day I will discuss about the error analysis. Okay, so thank you for watching this video, and stay home, stay safe. Thank you.